So today we are going to work with the ROS serial, and we want to communicate with the external microcontroller board from the ROS. First thing, you need to upload the sketch on the microcontroller board so that it can act as a ROS node. So this is, let me open the LUT file. So connecting Arduino to ROS, introduction to ROS serial Arduino. The objective of this experiment are to learn to connect Arduino with a ROS system, learn to set up Arduino and Ubuntu for the connection using the ROS serial protocol and ROS library, implement a simple toggle LED example and a slightly advanced push button step publishing in ROS. So this is the theory and methodology. Robot operating system is an open source robotics middleware, and you will be using it to control your Arduino. If you are interested in learning more, you can visit the website by clicking the link. So this is the Arduino microcontroller board. So what is ROS serial? This information is communicated with the help of the rosserial package. Rosserial is a protocol to send data through a serial interface. In a client-server rosserial implementation, a rosserial server is a computer running ROS, and rosserial client is the microprocessor that receives sensors data and transport it to the server in the form of ROS message. Rosserial server in this implementation is a publishing node, while ROS serial client is a subscriber node, although this can sometimes be the other way round. ROS serial client package is available for several microprocessor types including Arduino, STM32, embedded Linux and others, while ROS serial server package is available in Python or C++ version. So this is a block diagram how ROS serial can be used to communicate between ROS and microcontroller. This lab will go through the setup of Arduino and ROS serial. So installing the ROS serial package on Ubuntu. To install ROS serial in ROS Kinetic, if you use other version, you just need to change the name over here, okay? If you are using the Kinetic, then this is the instruction. If you use Noetic, like your virtual machine runs the ROS Noetic, then instead of Kinetic, you write just Noetic over here, okay? So this will install the ROS serial in your computer. After installing ROS serial, you need to install the Arduino IDE on your ROS computer. Okay. So how to install Arduino IDE? First you need to update your system. Then you need to run the command sudo apt install Arduino. This will install the Arduino IDE in your computer. Once you are done, then to launch Arduino, just click the icon or type Arduino at the terminal prompt. Okay. So it will run the Arduino in your computer, ROS computer. Okay. Then you need to set up the ROS library into the Arduino IDE. To set up the ROS of the library, you have to follow the steps that is shown on your left sheet. It will install the ROS library so that you can upload the ROS sketch on the microcontroller board. But there is a shortcut of this process. That means I have copied that ROS library and I have uploaded the zip file on your MS Team. Okay, so what you can do, you can download the zip file on your Windows and unzip the file and place the folder ROS library into the Arduino library folder under the documents of your Windows. Okay, Then from the Windows Arduino IDE, you can upload the sketch to the microcontroller board. Okay, so let me do it for you. Let me show it for you. Look at over here. This is the documents folder in the Windows. Let me go to the Arduino folder. This is the Arduino folder. Under the Arduino folder, there's a folder called libraries. Okay, double click the libraries folder and place the ROS library folder over here. Look at over here. This is the ROS library. Okay, so I have placed the ROS library folder over here so that you can upload the sketch from the Windows Arduino IDE. So let me go to the IDE, Arduino IDE, double click it. So file, new sketch. The new sketch, first you have to select what is the board, Arduino Uno at COM8. So it has detected the board. So fine, Arduino Uno is COM8. Make sure when you work with the standard microcontroller board, the name of the board and the port setting is very important. Okay, so that you can upload the sketch. So in this case, you see, look at over here, board is Arduino and port is COM8. So these two things must be done at the beginning. After you select your board and the COM port, go to the left sheet, and this is the Arduino sketch. That will convert your microcontroller board to a ROS node. So I'll just copy it from here. The explanation of this sketch has been given on your left sheet. Okay, so I am just copying the code. Control C. Then I am pasting the code in the Arduino IDE. So if you look at the code, at the beginning I have included the include ROS.h header file. Okay, then include the standard message.empty.h header file, then ROS node handle.h. Okay, this is the node handle for the ROS. Then message callback. This message callback function is the important function. This function runs one time, each time a message is received by this node. Every time this microcontroller node receives a message from the ROS, this callback function gets executed one time. For each message one time. If there are 3 messages, 3 times it will run. 10 messages, 10 times it will run. Okay. So this callback function runs every time a message is received from the ROS. Okay. So it defines what will be executed or what to do inside the callback function. So that job will get executed. Okay. So in this case, we want to toggle the LED. So we have written the command digital write, high digital LED. That means it will toggle the LED. Okay. It will toggle the LED. Next, we subscribe to the standard message by the subs function toggle LED at the message callback. So this toggle LED is the topic. Toggle LED is the topic. We are subscribing to the toggle LED topic, and in the ROS we will publish a message to this topic so that your microcontroller can get the message, and this message will be passed to the message callback function, and the LED will toggle. So in the setup part, we define that pin of 13 is the output pin. We initialize the node, microcontroller node, and we subscribe to the toggle LED by this command ns subscribe sub. Okay, so we subscribe to the toggle LED topic. In the loop, we spin once, delay once. That means we run this to keep the node alive. Okay, so that it will get the message. shutdown. Okay, so loop is running and waiting for the message. So let me upload this sketch to our microcontroller board. So click the upload button. It is compiling the sketch and it is uploading. Okay, upload is uploading, done uploading. Okay, now our microcontroller board is ready to act as a ROS node. Okay, it has a proper port over there to receive the message from the ROS. So next thing, we need to run the virtual machine. Okay, let's run the virtual machine. So before we run the virtual machine, some settings we need to do. So go to the settings, click USB. In my case, I have already added the Arduino node. Okay, look at over here. If you click this plus button on the right side, it will display all the available USB device. So in your case, if you are first time, you click the Arduino so that it will get added. So I have already done it. So Arduino is already added. Okay. So when you run the virtual machine, then from the virtual machine you can communicate to the Arduino. So click OK and start the virtual machine. How to check that your Arduino is properly, your microcontroller board is properly connected to the ROS? The process has been shown on your lab sheet, okay, or on the uploaded video. In the uploaded video, the process has been shown. In this case, to test it, we will do it directly. So first step, when you work with the ROS, you need to run the ROS master. Okay, if you want to run the ROS master, you need to source the ROS package. Okay, how to source the ROS package? Give the command source option ROS. Our ROS version over here is ROS Noetic. If you are confused, you can check the installation. Look at over here. Option ROS Noetic. Set up the bash. Okay, set up the bash. So into source your ROS installation. Option ROS Native. Set up dot bash. Okay, we have sourced the ROS package. Next thing, you need to run the ROS master. So how to run the ROS master? ROS code. Type ROS code to run the ROS master. Okay, in my case ROS code is already running, so it is giving a message that ROS code is already running. Okay, after running the ROS code, you need to connect to the external microcontroller board, okay, to the rosserial package. If the rosserial package is not installed in your machine, follow the lab sheet to install the rosserial package, okay, over here. is the command to install the rosserial package. So in my case already I have done it. It is already installed. So I will give the command to connect to the external microcontroller board. So what is the command? Look at over here. This is the command, okay? ROS run rosserial underscore python serial underscore node dot py, okay? Space then device TTY USB 0 or SCM 0. Okay, let me type the command. ROS run. Okay. ROS run, then rosserial underscore python underscore python then serial underscore node dot py. Then give a space, then device name, okay? Device TTY USB, capital letter, okay? 0. Okay, it is giving an error message. Why this is giving an error message? Because the device is not connected to USB 0. Okay, so let's try the other way. Instead of USB 0, use SCM 0. Yes, now it is working. So in your case, it can be USB 0 or SCM 0. Which one works? Just test it. Then that's the way. That's the port. Your microcontroller board has been connected to the ROS computer. Okay, so what is telling? rosserial python node, okay, and it's doing the connecting to device TTY SM0 at 57,600 baud, and it is requesting the topics because when you have uploaded the sketch on the microcontroller board, you have subscribed to the toggle LED topic. Okay, so it is requesting the topics. The note subscribe buffer size is 280 bytes. Set up subscriber on toggle LED. Okay, so it is setting up the subscriber on the toggle LED topic. It is a standard message, empty type of topic. So at this point, your microcontroller board has been communicating with the ROS computer and waiting for the message. Okay, and subscribe to the toggle LED topic and waiting for the message. So let's send some message to the toggle LED topic. Open up another new terminal. Okay, so let's publish the message. Okay, so what message we are going to publish? Let's look at your left sheet. ROS topic, publish, toggle LED, this is the topic name, and this is the message, standard message, empty type of message. So let's do it, ROS topic, publish. So we are publishing the message. What type of message? And what is the topic name? The topic name is toggle LED. and the message is standard message, okay, empty message. Standard message empty. So we have written the command to publish the message in that toggle topic. So let's run it. Now it is giving an error. Command ROS topic not found, but can be installed with sudo app install python 3 ROS topic. The error is happening because we did not source the ROS installation. So we need to source it, okay? Then it will not give you the error message. Source option ROS noetic. This is our version of ROS. Setup dash. So once it shows the ROS package, we can run the command from the ROS. So now run the command ROS topic, publish the message, and let's look at your microcontroller board. Your LED is off over here. If you look at your microcontroller board, you notice that initially the LED is off. Once you publish the message, the LED get turned on. It is doing the publishing and latching message for 3 seconds. So after you publish the message, the LED will toggle. Again, if you publish the message, again the LED will toggle. It will turn on and off each time. It will toggle. Okay? On. Again, publish the message, the LED will be off. So it will toggle the LED. Your job in this lab, perform the steps up to this point, plus modify this ROS topic publish message type in a way that the LED will keep on blinking. Blink 10 times per second, or 30 times per second, or 50 times per second, okay? So make it blinking at a particular rate. Once you are done, your lab is complete. If you have any question, you can ask me now. So if you look at your lab sheet, you see, LED is toggling. I think let me open the Windows version, dog version of the lab sheet. You see, the LED is toggling over here. Modify the ROS topic publish command on your ROS so that LED will blink at a particular rate. Give a search on Google how to modify the code. Okay. So that's your lab. If you have any question, we can go through now.